6.7 inverse functions. So what an inverse is basically switching the domain and range. So if this is my relation, again, relation and function are different words. A function means every x has one output. If this is my relation, the inverse of it will change the the input. So this is my output. It changes to my input. This is what I got. Once I plug this into the relation, this is what I start with. That's the difference between relation and, oops, you're not supposed to see that yet. What is the inverse of S? So if I'm going to write this, I'm going to write my inverse, and I have my X, Y. Everything of my output now becomes my input. And everything that's paired up with that output now is my output for my inverse. So you're switching. This was your input. This is what you put into the relation. This is what you got out. Inverse is now I flip-flop them. This is what I put in. This is what I get out. You flip-flop. So if I were to graph these, what is the graphs of the S and the inverse? So this is if I were to plot each of these 4 points. It looks like this. This is my inverse, so I'm plotting them differently. Now, if you look, looks a lot like if I had something like this, but it's just the opposite. So it looks the opposite. So when I'm finding my inverse, if I find the equation, again, you want to switch your input and your output. So right now, X is always my input, Y is my output. So I'm going to switch those up. X is still going to be my input, but now since I'm flip-flopping where they're located, I'm going to solve for Y, and this will be my inverse. So first I'm going to add over 1. And then the opposite of squaring something is square root. Now, this is where you have to be very careful because just like when we're solving, let's say if we had x squared is equal to 1 and we were solving just for this variable, when we take that square root, remember, we always have a positive and a negative answer. It's the same thing when I'm solving for variables. When I take the square root on each side, I'm still going to have this positive and negative square root of x plus 1. That's going to be to my output. Now, this is going to be my inverse. Right here. This is my inverse of this function. I want you to pause the video and try to do B by yourself. So you switch your X and Y here. First thing I'm going to do is subtract over my 8 and then divide by 2. When I divide by 2, I'm going to split up each of these and divide by 2. So this becomes, you could also write this as x over 2 or 1/2. This is 8 divided by 2 is -4. So this is my inverse. So again, this is my inverse of this relation. We didn't say if it's a function or not. Inverse. Now, if I'm looking at this, what are the graphs and its inverse? Then we have to decide if the graph represents a function. So if I were to graph this, if you remember, x squared is a circle, not circle, a u, and this moved on the outside means it moves down 1. You can also put this in your graphing calculator if you want to find out the table, but I'm going to do my vertex would be at 0, -1, like here. If I plug in -1 and 1 into my equation, I would get 0 out for both. If I plug -2 and 2 into my equation, I would get 3 out. So here's what my graph looks like. This is my original function. Now you have to decide, is this a function or not? Remember, if it's a function, that means I can do a vertical line test. So if I do my vertical line test, and I draw my lines up and down, this would be a function because every x value only crosses one y value. Here, now if I solve this first, I'm going to solve this for y. I'm flipping my x and y. I add over my 1. I take the square root. Remember, you need a positive negative. If you were to graph this now, actually, I'm going to show you how to graph this on your graphing calculator. What I'm going to do is go to my y equals, and because of this plus or minus, I have to actually have 2 different equations. So I'm going to have second square root of x plus 1. I have to arrow over, and then I'm also going to have a negative. So I have to make sure to push this negative key, and then second square root x plus 1. I'm going to go to my graph. So I kind of have an inkling of what it kind of looks like. We will be graphing these, but as you can see, it still looks like a U because it's put together. So I have it here. It's kind of like as if this just turned. That's what we're looking at. And then my points would look like this. So now when I look at this right here, I want to decide, is this a function? So again, if I do my vertical line test, this would be no, not a function. The reason why, because of the fact, function, because it goes through more than one point. Every x value does not have one, it has more than one. This one is, yes, it is a function. The inverse is not. The reason it's not is because of this plus or minus right there, because that gave us our top curve and our bottom curve. I want you to try to do B by yourself. Graph the first, find the inverse, and then also graph the second and say if it's a function of. So pause and try to do it by yourself. Here's what my first graph would look like. One thing when I look at this, I see that it's linear. Just like how up here, I knew for sure that it was going to be quadratic because of that squared. I knew my shape should have some sort of U. Here, because there's no exponent, I know it should be linear. Now, if I find the inverse of this, you switch your x and y. This is my inverse. So again, here's my new table. And if I were to plot those points, it look like this. So when I'm looking at this, if I do my vertical line test here, yes, this is a function. Yes, it's a function. If I do my vertical line test here, this also only goes through 1 point each time. So yes, this is a function. One thing you could notice is that when I started off with linear, I ended with a linear function. So every time the inverse of a linear function will be a function. Here I started with a quadratic. This is a function. But when I found the inverse, it was not a function. So every time you find the inverse of a quadratic, it will not be a function because of that plus or minus. So now when we actually denote, so actually show what a function is, we have to look at this function right here. The inverse is denoted or showed by with a -1. So whenever you see f to -1, that means it's inverse of the original. It's showing that that's the opposite. So if this is my function, I have to look, is this a function? So you could graph this. But one thing I can already tell is because there's no plus or minus here, I know that it's going to be a function. But just to make sure, I can go second square root of x minus 2, graph that. And when I look at this, each x value only has one y value. So yes, that's a function. Yes, it's a function. What is the inverse? So this right here means the inverse of the function, that -1. So I'm going to switch my input and my output. So now instead of having the name, so this is just the name, the function of f, y minus 2, opposite of the square root would be squaring something. So now I'm going to just have y minus 2, add over the 2. Oops, add over the 2. So my inverse function is going to be y squared plus 2. Okay, so now if I decide if this is a function, if I were to sketch the graph, this moves it up 2, so it looks something like this. And again, if I do my vertical line test, yes, that will be a function. Yes, this is also a function. Every input has one output. So every x, it does not repeat. So one thing I want you to do is look at this one. Is it a function? Find the inverse and solve this one first. So pause, try to do this by yourself. So yes, it's a function. I know that it is because it's linear. So a lot of times if you rewrite this as your mx plus b, that would be the function. So it's a straight line. If I find the inverse of this, so I switch my x and y here, and I solve for y, so this is my inverse function. You want to make sure to label it with your -1. Is this a function? Yes, that would be a function. Sorry. Is linear, and every x value has one y value. Input, output, you could also say there. So here, when we're talking about real world scenarios, you do not change what the variable is because this is talking about actual real life events. So in other words, do not switch variables when finding the inverse for real world problems. Never do it. Here's my function. If I read this, this says d is meters distance, t is seconds time. So here's my function. The first thing it says, how long in seconds does it take for the cliff there to reach the water below? Here's my function. I'm going to solve the inverse. So the inverse would be t for time. I do not switch these. Do not. So first thing I do is divide over the 4.9, and then I take the square root. Remember, you have a plus or minus. However, when we're talking about time, you don't really talk about a negative time. So now I'm saying cliff diver is 24 meters, so I can put that 24 in for my D right here, and I solve this in my calculator. I technically would get a positive negative, but you can't have negative time, so you have to make sure to also have units here. My units here would be S in seconds. So here's the function. Now we're talking about velocity. Velocity can be positive, negative, FYI. So when we're talking about time, no negative time, but velocity can be negative. So here's my equation. Again, I'm going to solve for my velocity first. So I'm going to multiply my 19.6 over, and then I take the square root. Here's that positive, negative when you take that square root. And now here's my velocity. Here's my equation for velocity. Same thing, I'm going to plug in my 24 here, and I get my velocity could be 21.69 meters square, or meters over seconds. If you're like, wait a second, you can really have a negative velocity? Take physics, and you will be on the right track. Okay. Last little bit here that we're going over. So when we're talking about the inverse, like so, just like how we have composition of functions, we can have the composition of the inverse and the first one. So first I'm going to find my inverse of this function. So my inverse, I'm switching my x and my y. This whole thing, I'm dividing by this whole thing, so I'm going to multiply this whole thing over. I get x times y minus 1. I want to solve for that y, so I'm going to first divide by that x, add over my 1. So here's my inverse function. When I'm plugging in, it's saying first find the composition at 1. So first plug this into your inverse. So I do this first, evaluate 1 at my inverse. I have 1 over 1 plus 1 because that's my inverse function. So I get 1 plus 1 is 2. So now I can evaluate my original function at 2. Here's my original function. Get 1 over 2 minus 1, which would be 1. If I look at B, first if I find the inverse of this, so switch your x and y first. That whole thing is being divided by x minus 2, so multiply by that whole x minus 2, and then divide by x and add over your 2. So here's my inverse function. Here's my inverse. Now it's saying plug 0 into my inverse first. So here's my inverse. And then plug that number into your original. When I plug into my 0, I can't do this. This is undefined. You cannot plug 0 at the bottom of the fraction. It's not in my domain. So this does not exist. You can also put D and E. And there we go. There's our 6.7 inverse functions. Fun stuff. Opposite location. Have a great day.